Okay, so we are live now. Okay, let me share my screen.
Yes,
Just a minute. Okay, so I have pasted the YouTube link in calendar also. Uh, okay, so let me share my screen. Okay, can you see my screen?
yes, sir.
Oh,
Yes,
fine, fine, great. Okay, so till week 9, I think you all of you had done the concepts like how you can differentiate between, I mean, what is the discrete random variable or what is the continuous random variable, right?
Yes, yes, sir.
Right? For discrete random number, what is the PMF? What is the
CDF,
CDF? And okay, what is the PMF basically?
probability mass function.
probability mass
Okay,
function.
this is the full form. I mean, what PMF tells us?
It's give one
Give one means
sum of
Probability of
all.
no
actually.
sum of all in CDF.
Yeah. So what PMF tells
It
us?
shows the distribution of the
Oh
probability.
yes,
Distribution of basically. Okay, so it tells us the what is the probabilistic behavior. Okay, basically it tells us what is the probabilistic behavior for each values of
each bill.
my each value of random variable x, right?
Random.
Correct.
Yes.
Yes,
I mean probabilistic behavior for each values of x means, let's say I'm saying x is taking some value, let's say I'm saying x1, okay, x2, x3, so on, let's say up to xn. So PMF is nothing but it tells us the probabilistic behavior, and that is what is the probability or what is the weight associated for this value x1, let's say p1. Okay, what is the probabilistic behavior for the value x2 is, let's say it's p2, p3, and so on, pn, right? This is something probability mass function gives me information for my random variable, right? How, what is the distribution of my random variable? Yes or no?
Yes, sir.
Correct? No. So, okay. What about expectation? Okay, so this is something. Suppose you want to know the some information about your random variable. So this is something I can tell, right? My x is a random variable. This is taking these all these values, and probability are associated with each value. This continues. Okay. What's the use of expectation? Any thought? Why we are moving to the expectation? Anyone? Feel free to say. Don't worry. Even though if not, we will discuss.
Sir, expectation tells us about the spreading of probability of each random variable.
Spreading.
Yeah. Means
No.
how much it differs.
Any other?
I think expectance should be to choose correct way and more efficient way. Like
Okay,
what?
what is the average? We have discussed in week 1 to 4, if I'm not wrong. What is the average? What average tells us for any data set?
Central tendency.
Yes,
Central tendency. It gives you a central idea about your data set. Like
yes, yes,
suppose you have
Yes.
data set of marks, right? Marks data set of any class, okay, and you want to explain that data set in a single number, so you are interested to calculate the average marks, right? I mean, simply if suppose I'm saying average marks of this class is, let's say, 80, then you will be having some idea for the a central idea through for whole class. Yes or no? Means I have represented my whole class, marks of whole class in a single number, correct?
yes,
So
sir.
expectation is the same thing. Like rather than explaining your random variable like all the values and probability associated with each value, so expectation tells us you it gives the information in a single value. Okay, yes or no? It gives you basically long run average.
Yes, yes. Long run will be
Yes, sir.
For example, suppose you rolling a die. What are the possible outcomes you will get? One, two,
6.
3, 4, 5, 6, right? And what will the probability associated with these values? 1 by 6,
1 by 6.
correct?
Yes, sir.
Now,
Yes.
so thing is that tell me expectation is something how I can compute. Okay, I will tell. I will explain this later. Okay, so this is something you got the idea. Means rather than suppose I say rather than explaining your random variable, giving the distribution or information about your random variable like this, each value and probability associated with each value. Suppose I'm going to give a expectation. I mean a single information in a single value. That is something I can do, right? The same thing we have done in week 1 to week 4. That's something average tells us, correct? The same thing I can do for my random variable also. Okay, so expectation is nothing but okay, expectation is nothing but defined as you have to do multiplication of, I mean we have to add all the values multiplied by with associated probabilities. Let's say it's xi, probability xi, I is equal to 1 to n. So if you see, what is this kind of weighted average? Yes or no?
Yes, sir.
I mean, see, this is something what is this? If you will expand this, I will get p1 x1 into probability at x1 plus x2 into probability at
Probability of
x2
x2.
plus so on xn into probability at xn. Correct?
Yes, sir.
So this is what? So this is something I have to calculate from this information, right? Probability mass function from the probability mass function. Yes or no? So this is something weighted average. Okay. So expectation of any kind of any discrete random variable, it gives us the information about weighted average of that random variable. In simple term, I can say it's a long run average. Okay, what do you mean by long run average? Actually, okay, suppose I roll the. I'm going to take this example. I'm rolling the die. What are the possible outcomes my x will take? Random variable. It will take 1, 2, 3, 4, 5, 6, right? And what are
Yes.
the probabilities associated with each values? 1 by 6, 1 by 6, 1 by 6, 1 by 6, and 1 by 6. Okay, 1 minute. Okay, tell me what will the expected value of this random variable? 1 into 1 by 6. Basically,
Yes.
I have to do summation of x into px, right? So basically, I have to do 1 into 1 by 6 plus
Plus 2
2
into 1 by
into 1 by 6. See, if you see x into px means value into corresponding probability. So 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6, right? So that means it will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6. What is
yes.
the value? I think 6, 5, 11, 15, 18, 20, 21 divided by 6, right? So the thing is 3.5. Okay. Now thing is that what is the meaning of this 3.5? Anyone? Is that mean if you roll the die, will you get the outcome as 3.5 or is the meaning is different?
It's like different, ma'am says in lecture. Like it is
Yeah,
not the value of exactly.
correct. So basically, I told you it's a long run average. It's a theoretical average. What does this mean? It means suppose you are going to roll the die a large number of times, right? Then
Yes.
average of all the outcomes, right?
Yes.
So
It
you
can be
can,
3.5.
yes, you can expect the average of all the outcomes as 3.5. So that's why it's called the theoretical average or long run average. So some sort of idea are you getting? Means it gives us, I mean, you are explaining or if you are describing your random variable in a single value rather than saying giving the information like this. Okay.
Yes.
Okay. Any practical real life example for expected expectation? Anyone? Okay. Let me give you one scenario. Suppose there is a one game. Okay. In that game, you toss a coin, fair coin. Okay. If you are going to let's say you are going to toss a fair coin. Okay. Then I'm saying you will win. Let's say you will win. Let's say $1. Okay. And if it tails, I mean, if coin lands on tail, or you will lose $1 if it's head. Okay. Now, suppose I'm saying my x random variable represents the amount of money you win a single toss of the coin. That's the amount of money. Okay, you will win in a single toss of the coin. Okay. Now tell me whether you will play the game or not. And how will you decide?
So first we find that the winning chances how much and losing chances how much.
Yes.
Basically, I can find whether I'm I can find the expectation value, right? If
Yes. Yes.
expected value of my random variable will be in positive, then I will play the game.
If
Otherwise, I
negative.
will in negative. That means I will prefer not to play the game. Yes or no?
Yes. Yes. Yes, sir.
Correct. Now, how will you decide? Now,
Once
thing is
again,
that, sorry.
repeat once again, sir.
Yeah, so I'm saying, suppose there is a fair coin, okay, and game is you have to toss the coin and you will win $1 if tail is there, and you will lose $1 if head is there, okay. And I have defined one random variable amount of money you will win in a single toss, okay. So I mean single toss of the coin. So thing is that whether you will play the game or not, that is the question, okay. So now here I can find the expected value and I will decide whether I will play the game or not. Okay. Okay, first of all, I have to find the distribution of x, right? Okay. Let's do like this. Okay. So I will, okay, what are the possible values my random variable x will take here?
How many time we one coin only, and
One coin is there and you have to decide for a single toss. So what are the possible values your x will take?
Head and tail.
No, that is not a value. That are the
random
outcome.
value,
0
random
and 1.
variable like
See, you will win. You are going to win $1 if tail is there. You are going to lose $1 if head is there. So
zero and one.
why zero?
Uh, 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 Number of head appearing
No.
zero and
See,
Minus one and one.
correct. -1 and 1. See, my random variable is what is representing what amount of money, right? Either I will, if head is there, I will win, or I will lose.
oh,
Are
uh,
you getting?
yes, 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 sir.
Okay. And what will
I
the
am
probability associated with this?
But sir, probability is not negative, no?
It's not
Only
a
related
probability, it's a
to
value. See the things clearly. It's not a probability, it's value.
Yes, sir.
Okay. And what is the probability associated with this value?
Half
One half,
one
right?
by two.
1/2. Why 1/2? Because this is the fair coin, and I will get one when tail is there, and one I will lose one when head is there. Probability will be half and half. Yes or no?
Yes, sir. Yes,
What
sir.
about expected value?
Yes, sir.
So I have to do summation of x into px, right? So I have to do 1 into probability at x equal to 1 plus -1 into probability at x equal to -1, right? So it will be 1 into half minus 1 into half. So it's a 0.
yes.
Wrong? So what will be your decision now?
Leave the game.
Okay, what conclusion you can make from here? You
No,
got expected value of 0. That means,
Not
okay,
playing the game.
okay, what is the meaning of this?
nothing, sir.
You are not going to profitable.
Basically, I will say on an average over many. Okay, let's say there are. I mean, you have to toss the coin. Let's say some 100 times or 10 times, right? Even though over many coin tosses, okay, you will neither win or nor lose money. Okay,
Yes,
that is something, right? Neither win nor lose
lose
the money.
money.
If, for example, in any scenario, expected value of x is coming out to be negative, that means you will lose the money. And if expected value of x is coming out to be, let's say, in some positive number, that means you are going to win
Win
the.
the money.
Okay, some idea is clear about expectation of random variable.
no,
Yes.
sir.
Okay, yeah, fine. Okay, let's do the expectation of some let's say for some distribution. Okay, suppose I'm saying x is following Bernoulli distribution. Okay, let's say with probability p. I don't know whether p is half or not. Okay, so what are the possible values x will take? 0 or 1? Okay. And what is
Yes.
the probability associated with each value? It's a, let's say for p, so for 1 it's a p, then for 0 it will be 1 minus p, right?
Yes.
Okay. So what is the expected value? You can find summation of x into px. That means 0 into
0 into
probability
1
x
minus.
equal to 0 plus 1 into probability
P.
at x equal to 1. So 0 into 1 minus p plus 1 into p, that means p,
P.
right? So that is the something expected value of your Bernoulli random variable, right? Yes or no?
Yes, sir.
Okay, how many of you rough and paper, do you have pen and paper right now?
What, sir?
Do you have pen and paper?
Yes, sir. Yes,
Okay.
sir.
Yes, sir.
Okay, how many of you know the discrete uniform distribution?
Discrete uniform.
Distribution or random variable? No one? Okay, let me tell you. Let me introduce you. What is the discrete uniform? So basically, discrete uniform random variable is nothing but it's a random variable. Okay, by means, okay, by means term. If you say discrete means it will take distinct value, discrete value, and uniform is probability will be same. Okay, so
Equally
uh,
likely,
you
like probability.
correct, correct. So suppose x is something taking value x1, x2 up to xn, then let's say probability for each value is same. Let's say 1 by n. Okay.
Yes.
So this is something called discrete uniform random variable. Okay. So okay. So now if we see probabilities are equal, let's say a discrete uniform random variable, you can, for example, I can take that. Uh, I mean, I'm rolling a fair die. Okay.
Yes.
Okay. And x represents the outcome of die. Correct. Now, so now it's a discrete uniform or not? Because if you
Yes.
see, it is taking some distinct values, right?
Yes.
And what is the probability associated with each values? It's same,
Same.
right? 1 by 6 for each values, okay? Okay. Now, so tell me the expected value of x for the above discrete uniform, right? Not for this in general.
N plus 1 divided by 2.
N plus 1 divided by 2, okay. What about others?
N plus 1 by 2, sir.
Okay, okay. N plus 1 by 2, by how? So it's, I think I have not take x1, x2, xn as 1 to n. I take in general, right? So by n plus 1 divided by 2, it's possible only when it's 1 to n, right?
Yes, sir.
Correct or not?
Yes, sir. But then in
Yeah.
this case,
Yeah, suppose these are the some n distinct value, right? It's possible.
then we can say sigma xn, sigma xi I equal to 1 to n upon n.
Yeah, basically, all of you have done like this. There are some n distinct value, right? Okay. And probability for each value is same. Let's say 1 by n, 1 by n, 1 by n, and up to 1 by n. So how I can compute the expectation of x? It's nothing but summation of x into px. So that means 1 into 1 by n plus 2 into 1 by n plus 3 into 1 by n up to n into 1 by n. So basically 1 by n I can take common. So it will be 1 plus 2 plus 3 plus up to n. And this is what? Sum of n natural numbers, right? So sum, it's nothing but n into n plus 1 divided by 2. It will get cancel out. So it will be n plus 1 divided by 2, right? And this is the correct one.
Yes.
The same thing you can directly apply for this case. If you see expected value of x, we got n plus 1 by 2. What is the n here? 6. 6 plus 1 by 2, and it will be 7 by 2, which is the 3.5, right? The same thing we got in the previous case. Where it is? This case, right?
Sir,
Okay.
if there is a discrete random variable, then
Hmm.
it must be necessary that that every value of natural number should exist,
Hmm.
like x equal to 1 there, then
Hmm.
2 also there. It could be possible that only x equal to 1, 3, 5 there.
Yeah, yeah, it can be anything. Suppose, okay, suppose I'm saying you are going to roll a die, okay, and you can define random variable any kind, right? Suppose I'm saying x represents the outcome as odd number, then it will be only 135, right?
Yes, sir.
Correct. You
Then
can
in
define
this case
outcome.
also expect this formula will exist.
Yes, yes, why not? It's not like, okay, see, it's only about what is the possible values your random variable is taking and what is the probability associated with that value. That's all. You have to find possible values and probability associated with that value, and simply you can compute the expected value of x. Okay.
Sir, in this case, I am
Hmm.
confusing in previous slide, like why we take 1 and minus 1, why we can't take 0 and 1.
Okay. What is your x represents basically? It represents amount of money, right?
Yes, in amount of, or in case of represent the number of head outcome, then it can be
That is the
possible.
difference. Then you can simply say, okay, suppose I'm simply defining, I will x will take value 1 if head is there, it will take value 0 if tail is there. That's Bernoulli, right? You
Sir,
can simply do.
sir, can
The
we
thing is
use
that,
that? Sir, can we use that formula that you wrote? Uh, Ex is equal to n into n plus. Ex is equal to n plus
here,
1 upon 2 in
here,
expectation finding. Yes, sir.
okay, can you use that one? Tell me
Yes, sir.
how.
Mm, no, no, here not, sir.
Here not, right? So actually
Yes, sir,
that
here
is
not,
something,
sir.
okay, why I use directly, because this scenario was the same as this scenario,
In
okay.
this scenario, we can use this.
Okay. Yeah, yeah. So basically here we are discussing x is okay. So it depends how we are defining my random variable. Accordingly, my random variable is going to take the values, right? Here I'm defining x is what amount of money you will win, right? Either you will lose minus. I mean, if you lose, it will be -1. If you will, it's a 1, right? That is the only two possible cases. Yes or no?
Yes, sir.
Okay.
If,
Suppose. Hmm,
in
yeah. Go
this
ahead.
case, we will be say like if we lose then 0, and if we win then 1. Why it cannot be possible?
Because random variable is I define like this, right? It depends on the how we are defining the random variable. Okay, what is the your random variable? It's the amount of money. I'm not defining I will win or lose.
Oh, amount
Okay,
of money. Yes, yes,
correct.
yes,
Got it.
yes,
Let's say, for example, this die case, it can be anything. I can define my x is the even number.
yes,
Okay,
yes,
I can define x as a, let's say, numbers greater than 2, or sum of, let's say I'm rolling the die 2 times. Okay,
yes, yes,
okay. Suppose I'm going to roll the die 2 times. Suppose this is my experiment. Okay, suppose I'm going to roll the die twice, and this is my experiment, and I can represent x anyhow, right? Let's say on both die there are some same number, or x represents the sum of dice 7 or more than anything, right? Accordingly, your x is going to take values, right? And
yes. This that's why I am confusing, because in random variable we can take any value.
yeah, so it depends how we are defining. Okay, suppose I'm defining x. Let's say I'm interested in marks. Suppose I'm defining x will take marks less than 50. Then you have to take only, I mean, your random variable x will take all those marks, I mean, which are less than 50, right? So it
Yes.
depends how we are defining the value. Sorry, my random variable. Accordingly, my random variable is going to take value. Okay,
Okay. Okay.
fine. Yeah.
I got it. Okay.
Okay. So expectation we have done for a single random variable. Okay. Now what about function of random variable? Okay. Means expectation I'm defining x into px. Suppose I'm saying what about expectation of any function of random variable? So it's nothing but, suppose you are defining, let's say, y as a gx. Okay. So it will be expectation of y. It will be summation of y into px. Okay. Let's write like this. One second. So it will be summation of gx into px. What is the meaning of this one? Okay, suppose I'm saying x is taking 1, 2, 3. Okay, let me take only this 3 value. Okay, and probabilities are associated with this value are 1 by 3, 1 by 3, and 1 by 3. Okay. What will be the expected value of x? It will be 1 into 1 by 3 plus 2 into 1 by 3 plus 3 into 1 by 3. Okay. So 1. Okay. So expected value of x we can find from there. Okay. What about suppose and ask what are the about expected value of x square? How will you find? Okay. What is the x square represent? This is nothing but function of your random variable, right?
Yes, sir.
Okay. Okay. First of all, I have to find the x square. Okay. What are the possible values x square will take? Let's say I'm representing as y. It will take 1,
4
2.
and 9.
What will the probabilities?
One,
Probability will
one
be
by
1 by
same.
3, 1 by 3, 1 by 3. Okay. So what
Yes.
about expected value of x square?
1 by 3 into
1
4
into
by
1 by
plus
3 plus 4 into 1 by
So it
3
will
plus
be
9 into 1.
basically, yeah, 1 into 1 by 3 plus 4 into
4
1
by
by
3.
3 plus 9 into 1 by 3. So
Yes.
it doesn't matter what about, I mean, it's a, suppose whatever is the function of your random variable, it will be simply gx, I mean, function of that random variable into probability associated with each value. Okay. So, okay, this is clear somewhat. Okay.
Yes, sir.
So there are some properties for your expected value of x. What that property says, suppose I have two random variables. Okay. If I have some two random variables, then how will you do? Okay. And suppose I have two random variables and I'm saying I have to find the expected value of x plus y. So this is the same as expected value of x plus expected value of y.
Why?
So
Yes.
this is the one property you can apply for in the case of expectation of a random variable. Okay. You have two kind of random variables. Suppose okay, expectation of ax where a is suppose any constant is there. Okay. How will you compute? It will be
A
simply a times
A into
expected value of x. Okay. If you want, we can derive. Let's say in this case, expected value of x is, let's say how much is coming out to be 3 to 5, 6 by 3, it's a 2, right? Okay.
Yes.
Expected value of x 2. Okay. Okay, let's take that example. So expect x was 1, 2, 3, and probabilities associated with each value was 1 by 3, 1 by 3, and 1 by 3. Okay. And what is the expected value? Expected value of x was 2. Okay. Tell me, if question is expected value of let's say 3 times of x. Okay. Then it will be, what will the function first of all? 3 times of x. So it will be what is the possible values I will expect?
3,
3,
6, 9.
6, 9.
Sir,
Okay.
can you search page number 6?
Yeah, I will come to 1 second. So it will be 1 by 3, 1 by 3, and 1 by 3. If you see what is the probability associate, sorry, what will the expected value of now? It will be 3
1.
plus 6 plus 9
6.
divided by
Yes.
3, right?
Yes. Yes.
So it will be now 18 divided by 3, which is nothing but 6. Correct?
Yes,
So what is this? Is this same as 2 times of expected value of x?
yes, sir.
Yes, sir.
Right? Okay. So this property is fulfilled, right? Expected value of any constant ax equal to nothing but a times of expected value of x, right? Got it? Yeah. Someone asking, yes. Okay. This these two properties. Okay.
Sir, I have a one doubt.
Yes.
Sir, every time it is necessary to probability associated is equal to each other. Like one probability associated 1 by 3, 2 associated 1 by 3, 3
No,
associated
no,
1
no.
by 3.
It's not necessary. It depends on how we are defining the probability.
Okay.
Okay. It
Thank you,
may
sir.
be some, let's say 2 by 6, 2 by 6. I mean, it's again 1 by 3, but let's say it's something two probabilities are 1 by 4, 1 by 4, then 1 minus 2 by 4. I mean, this it will be half, right?
Yes,
I
I
mean,
got it.
basic properties, sum of all the probabilities should be 1 and probability should be greater than 0. Okay.
Yeah, sir. Thank you.
So, I
Sir,
mean,
but
these two properties should be fulfilled. I mean, sum of all the probabilities should be equal to 1 and probability should be
Great.
greater or equal to 0. Okay.
Zero.
These two properties should be fulfilled. Only then it will be PMF of your random variable.
Yes, sir.
Okay. So,
sir, but in case of discrete
mhm.
uniform random variables, the
Mhm.
probabilities are same, na, that you have taken
Yes, yes,
example.
yes.
Sir.
It can be. It can be. Okay. So next is, suppose I'm going to add a constant to this random variable. Okay. Then it will be same as a plus expected value of x. So basically, this is why this is happening. The expectation of any constant is same as that constant. Okay. So
Uh,
if you apply here, okay, it will be expected value of a plus expected value of x, and we know expectation of any constant is nothing but a plus. I mean that constant, then it will be a plus expected value of that random variable. Okay. This is something we can apply. Like suppose that marks example. Suppose teacher wants to give 2 marks, or there is any discrepancy in any question, and he wants to award 2 marks in for every student, right? Then you can simply apply a plus expectation of that random, something like that. You can simply add. I mean, you can apply this problem. Okay. Okay. Is this clear? Any doubt?
yes.
Okay. The same concept you can apply
Yes, sir.
here. Like, okay, suppose you can simply do what is the expectation value of 3 plus x. Then you have to apply 3 plus x. So it will be 4, right? 5 and 6, right? 1 by 3, 1 by 3, and 1 by 3. If you will find expected value of x, then what it will be? It will be 15 divided by 3, which is 5, right? Now,
Fine.
is this
Yes.
same as 3 plus expected value of x, right? Because expected value of x is 2, correct? So it will be 3 plus 2, which is 5. Okay. So far, it is clear.
Yes, sir.
Yes, sir.
Any doubt?
Yes, sir.
No, sir.
Okay, fine. Okay, so let me first cover the remaining two concepts, variance and standardization. Then we'll take the questions from activity. Will that be fine? Or
Yes, sir.
okay?
Okay, sir.
Yes, sir.
Okay, so we have discussed the expectation. Why? Okay, what is the need of variance and what it tells us basically?
It tells the spread.
Spreadness of what?
Spread of
Spreadness.
random variable.
Yes.
Okay. Okay. So far we have discussed expectation, right? What expectation tells us? See, if we want to describe my random variable in a single number or in a single value, I can find the expectation of that random variable, right? And if you
Yes.
see, expected value of a random variable gives the weighted average of the possible values taken by the my random variable, right? But expectation doesn't not gives any information, or it doesn't tell anything about variation or spreadness of these values, right?
Yes.
It just gives you a information in a single value. It doesn't gives information, or it doesn't give information, or it doesn't tells us anything about variation of
Spreadness of data.
values taken by random variable, right?
Yes.
So for this, variance comes into the picture. Why? Because variance tells us spreadness. I mean, it's nothing but measure of spread. Okay. I think these all things we have done in week 1 to 4, right? It gives us
Yes.
measure of spread, and what it tells basically, like it gives you spreadness from its mean. Okay, basically, not variance of any random variable defined as nothing but expected value of random variable minus mu whole square. What is the mu? Mu is nothing but expectation of your random variable. Okay. So what's the need of variance? Let me take one example. Suppose in a like, I mean, why we are interested in know the variability of my data. So suppose there is two colleges, two universities, University A and University B, right? In University A, let's say I'm going to take some I will give you some sort of idea, and we'll move to the about random. Okay. Suppose in university A, there are some, these are the packages of, let's say, in lakhs or in crore, whatever, of some five random students, and in university B, these are the things, right? Now tell me, what is average annual, what is the average package for this case?
3.
3. What about this average package for the university B?
Also
3.
3 like.
No.
3.
So on an average, both are same, right? Okay. But is this true?
No.
No. If you see the variability, there are variation in packages of university and university B, right?
Yes.
Correct. So that's why variation comes into the picture. We are able to know the variability or spreadness of my data set from its mean, right? If you see how we are finding the variance, we are simply doing summation of xi minus x bar whole square divided by n and n minus 1, depending on the whether I'm going to use the sample variance population. If you see, if you focus only on this value, what we are doing, 1 minus 3 square plus 2 minus 3 square plus 3 minus 3 square, something like that.
Yes.
Correct. Okay. Why we are not? Why we are doing only square? Why we are not doing 1 minus 3 plus 2 minus 3 and all? If
It.
you will do this, it will give you 0,
Yes.
right? Why we are squaring? Because we are observing the
So
spreadness from its
it
mean,
is
right?
it is like a sample variance or a population.
I see. We are not focusing on whether sample population. We are just uh, focusing on what variance tells us. It gives you how much variability is there from its mean. Okay. The same concept is applied for the variance of your random variable. So variance of random variable x is defined nothing but expected value of x minus mu whole square, means deviation from its mean. Okay.
Mean.
So this is the one formula you can apply for case of variance. Okay. Another is something, if you will expand this one. Okay. So what you will get? I can expand, right? X square plus mu square minus 2 mu x, right?
Yes.
So if you, I mean, I can take expectation inside the bracket. It will be expected value of x square plus expected value of mu square minus 2 mu expected value of x, right? So if you see, mu square is what? It's a constant value, right?
Yes, sir.
And I know expectation of a constant is nothing but that value,
Yes, sir.
right? So it will be mu square minus 2 mu. And what is the expectation of x? It's a mu,
Mu. Yes, sir.
right? So it will be expected value of x square plus mu square minus 2 mu square. This is same as nothing but expected value of x square minus mu square.
Yes.
It will be expected value of x square minus expected value of x whole square.
Yes. Yes.
Okay, so this is the another form of to find the variance. Okay, you can use this one. I mean, we are using frequently this formula because, I mean, it's something like, suppose you have founded the expected value of x, I can simply find out the expected value of x square, right?
Yes.
And then you can apply this formula, you will get the variance of that random. Okay. Some sort of idea is okay, clear?
Sir, mu is the mean here.
Yeah, mu is the expected value
Expected value.
of your random variable. Okay, so let's take that example, dice example. So for that, it was 1 2 3 4 5 6, right? And what was the probabilities? It was 1 by 6, 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 and 1 by 6. And we found expected value of x as 3.5, right? Yes or no?
Yes, sir.
No, I can compute the x square. What will be x square? It will be 1, 4, 9, 16, 25, 36. Yes or no? What will the
Yes.
probabilities associated with each value? Again 1 by 6, 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 and 1 by 6. Now, what about expected value of x square? So I can simply apply this concept, right? 1
Yes,
Yes.
sir.
into
1 into
1 by
1
6.
1
Okay, so
upon
I'm
6
just
4 plus 4 into 1 upon 6.
okay. So it will basically 1 plus 4 plus 9 plus 16 plus 25 plus 36 divided by 6, right?
Yes.
So
Yes, sir.
let's add this. So it will be 16, 9, 25, 50, and 55, 55 plus 36. How much is coming? Anyone can calculate? 55 plus 36.
91 by 6.
91
91.
divided by 6, right? What is the value? 91 divided by 6? It's
15.1.
yeah. Let's do in some 90 divided. And for this, it was 21 divided by 6, right? If I'm not wrong. So I can find the variance of this random value. What is the variance? It's nothing but expected value of x square minus expected value of x whole square, right? So it
Yes.
will be 91 divided by 6 minus 21 divided by 6 whole square. I mean you can calculate the value you will get, that will represent the variance of that random. Okay, is this clear?
Yes, sir.
Okay, let's do in general. Then okay, let's do for okay. Now you will tell me. Suppose I'm saying x is uh, following Bernoulli distribution with probability p. Okay, tell me. I will give you x is taking value 0 and 1, and probabilities are associated with, let's say it's a 1 minus p and p. Now tell me what will be the variance of x. I mean just let's take 2 minutes, okay, and calculate it and do let me. I will be back in 2 minutes. Okay, so Prashant has written in the chat box p into 1 minus p. So did everyone got this value, or everyone got it, or you are trying?
Yes, sir, I got it. P into 1 minus P.
So basically, what is the variance? It defines defined as expected value of x square minus expected value of x whole square, right? Now, let's make it equation number star. So what is the expectation of x? It's nothing but summation of x into px. That means 0 into probability at x equal to 0 plus 1 into probability at x equal to 1, right? Okay. So it will be 0 into 1 minus p plus 1 into p, which is nothing but p, correct? So we got this expectation of x. Now what about expectation of x square? So to find the x square, let's say this is x, what is the possible value it will take? Again 0 and 1, right? What is the probabilities? 1 minus p and p. Yes or no? Am I
Yes,
audible?
sir.
Yes,
Yeah.
sir.
Okay. So what is the expected value of x square now? So it will be again 0 into 1 minus p plus 1 into p, which is nothing but p. Now, how variance is defined? Variance is defined as expected value of x square. So what is expected value of x square? It's a
P.
p minus p square, right? So I
Yes.
can take 1 p as a common. It will be p into 1 minus p. So this is something variance of your Bernoulli random variable. Okay.
Yes.
So this is, I mean, you can use this concept like in week 11, you are going to study about discrete random variables. Okay. So by this apply, you can apply this the same concept to find the expectation of that random variable. Let's say binomial, hypergeometric, geometric, negative binomial, whatever Poisson and all. There are some lots of discrete distribution and all. You can find this. You can find the variance of that random variable also. Okay. So is this idea clear?
Yes, sir.
Okay. Fine.
Yes, sir.
Okay. So there are some property. Okay. Tell me what about variance of a constant? Suppose A is nothing but A is a constant. Tell me what about variance of a constant?
Variance of a constant
Yes.
is a square, like square of constant, like
No. How?
So
uh,
0.
Okay. Zero. Zero is the correct, but why?
So, so because it is a constant, so there is no variation.
Okay.
We can also find out through formula.
Formula. Correct. Yeah. That is something. See, variability of a number is what? It's simply zero, right? Because I'm
okay.
just asking what is the variance of two? It's a zero, right? I mean, it's
Yes, yes.
simply you are going to find expectation of a two. It's nothing but two itself. I mean, what is the average or what is the expectation of that number? Okay, why we are getting this two as, because I'm saying x is taking only one value two, and what will the probability? Probability will be one, because if it's
Yes.
only one value, then what will the expected value? It will be
Two
summation
into
of
one.
x into px, which is nothing but two into one. That's why we are getting expected value of a
Two.
constant is two, right?
Yes, yes.
If
Okay.
expected
Yes.
value of constant is two, and how we can find the variance? Variance is what? Expected value of x minus mu whole square, or expected value of x square minus expected value of x whole square,
Yes, yes,
right?
yes.
What about expected value of x square? If it's a 4, then expectation will be 4,
Yes.
right? I mean, if you are talking about general, it will be a square. And what is the expected value of x? Any constant a?
A
It's again a. A square minus a square is what?
0.
0, right? So variance
Okay.
of a constant is nothing but 0. Is this clear?
Yes, sir. Clear, sir.
Okay. Now, what about variance of any constant into that random variable? So that is nothing but it's coming out to be square of that random variable. Okay, I mean square of that constant
Variance.
to variance. How we are getting? So variance of, let's prove this one. So variance of ax is nothing but, if you I'm going to with the concept. So it will be expected value of a square x square minus expected value of ax whole square, right? Yes or no?
Yes, sir.
Correct. Now, what about this is the constant? So I can take outside a square expected value of x square, right? Yes or no?
Yes, sir.
Yes,
What
sir.
about this? I can take a as a outside, it will be expectation of x whole square, right? So
Yes.
now from here I can take a square is the common. Now if you take a square, I mean a outside from this bracket, you will get a square, right? And expected of x whole square, right? Now I can take a square as a common. I will get expected value of x square minus expectation of x whole square, right?
Whole square. Yes.
Now, right? So what is this now? This is nothing but variance of x,
Yes.
correct? We got it, right?
Yes.
Hmm? Got the idea? I mean, did you get the proof behind it, right? Now,
Yes.
what about variance of, suppose I'm going to, so in Week 4 we have discussed, right? What will the effect if I'm going to add a constant to all the
Yes.
values
Yes.
in the variance? What was the effect? No, right?
All things is done.
Right? That
Yes,
means
sir.
it's the same as variance of x,
Yes.
right? Should we
Because
prove?
adding and subtracting constant in
Doesn't matter,
various
right?
now.
You can prove
Yes.
itself here. So this means what? Expected value of nothing but a plus, or I can simply do from here. So what about expected value of, sorry, variance of x? I can use this formula, expected value of x minus mu whole square, right? No, no, no. Vishnu, it's not proof we are going to ask in term and all. There will be some MCQ, MSQ, and NAT question, but I'm proving because you know what is the algorithm behind it. I can simply
Okay,
tell you the
okay,
result if you are okay with that.
okay.
Okay.
I got.
Yeah. So basically, so if what about variance of ax? So if you know, I can simply add a plus x, right? and in the mean itself, mean will be added, right? Yes or no? Are you getting?
Yes,
B
sir.
minus A minus, it will be, if you see, A will get cancel out and I will get again a expectation of x minus mu whole square, which is nothing but variance of
variance,
x. It doesn't matter whether I'm going to add a constant or subtract a
subtract a
constant,
constant,
but it will be affected by the multiplication of any
division.
constant in that random variable. Okay.
Yes,
Okay. So far it is fine.
yes, sir.
Okay. What about variance of two random variables? Let's say I'm saying there are two random variables. Let's say x plus y. What about variance of these two? In expectation, there was addition of two random variables and we got expected value of x plus expected value of y. But what about variance of x plus y? Tell me.
In this case, we can't say like variance of x is plus variance of y is equal to variance of x plus y.
Yeah, basically I will tell you. So thing is, if you are going to add two constant, right? Variance of not two constant, two random variables. So variance of x plus y, it coming out to be in general variance of x plus variance of y plus two times of covariance of x comma y. It's, I mean, we are not going to in that much depth. I will give you some general idea. Okay. So we can't say variance of x plus y same as variance of x plus variance of y. We will say only when, suppose, okay, if x and y are independent, right? If x and y are independent random variables, okay? So that means covariance between these two random variable is 0.
Zero,
Okay.
yes.
So if covariance will be 0, right? Then only then I can say variance of x plus y is same as variance of x plus
Variance
variance
of
of
y,
y. But in the case of expectation, it doesn't matter whether it's a dependent or independent. Okay.
independent.
But in case of variance,
So,
if you want, yeah, let me finish. Variance of x plus y same as variance of x plus variance of y. Then x plus, I mean, x and y should be independent. Okay. Yeah. Tell me. Yeah. Go ahead, please.
sir, can you please repeat how you two covariance
Yeah,
x
it's
comma
okay.
y?
We are not
Yeah.
going in the derivation and all. I'm just giving you the explanation. Actually, if you
Okay.
find the variance of x plus y by this formula or these things, so this is same as this one. Actually, okay. I mean,
Okay.
simply you can apply variance of x plus y, then it will be expected value of x plus y whole is x plus y square minus expected value of x plus y whole square, right? You can expand those formula. I mean, I'm talking about like this formula. The expectation of x plus y square minus expectation of x plus y whole square. If you expand x square plus y square plus xy, right?
Oh,
2xy.
okay, sir, I got it. Okay.
Then you will get covariance. Okay. I'm not going to in that depth. I will just give just idea, right? So from
Okay,
there
sir.
you can find the above equation actually. Okay.
Okay, sir, move forward.
Okay. Yeah. So now you got the idea. Whenever x and y will be independent, only then I can simply say variance of x plus y is same as variance of x plus variance of y, right?
Yes, sir.
Okay. What about this? This is only about two random variables, right? What about let's say more than two random variables? So I can simply say, suppose I have some x1, x2. Let's say I have some n independent random variables. It should be independent random variables. Some of then variance of some is okay. X1 plus x2 plus so on. Xn will be what?
X1, variance
Variance
of
of x1
x
plus
plus variance of
variance of x2 plus so on variance
variance
of
of
x. I
xn.
mean, in short, in general, I can say simply say variance of summation of our sum of random variable is nothing but sum of their individual variances only when my xi's are independent. Okay, is this clear so far?
Yes,
Any
I
doubt?
know.
Any doubt?
No, sir.
Fine. Now, so should I move to the next concept, standard deviation?
Yes, sir.
Okay, fine. So, okay, tell me what you have learned about standard deviation or what's the need of standard
It's
deviation.
a square root of variance.
That is something I'm the standard deviation is defined, definition of standard deviation is there, right? Standard deviation nothing but positive square root of the variance. But why? What's the need? I mean, suppose you got variance as a variance of a random variable is 4 and you are saying standard deviation is 2. I mean, what's the difference? Why we are doing that? Why we are taking the square root of?
So because we get the square of the units, and to rectify that problem, we need standard deviation.
Correct, correct. Basically, we are going to get the final answer in a same unit. Okay. For example, your x is going to represent the let's say weight of some person, okay, weight of some people, let's say 10 and whatever, I don't know, okay. Then what will the variance of x? Let's say something it's coming out to be a whatever, it will be coming in kilogram square, right? But your original data was in kilogram, okay. If you will take the square root of this kilogram square, then you are going to get some value into kilogram, right? Then this is the unit is the same as the original data set.
Yes, sir.
Now, so you will be able to compare the data set. I mean, you can easily tell such that, yeah, this is the something spreadness or deviation about my data set in as original unit, right? So
Yes.
that's the need of standard deviation. So basically, standard deviation of x is nothing but square root of variance of x. Okay, just give me a minute. Okay, so this is something. Okay, so basically, it's I mean, you suppose you can find the variance of x by the formula, like you can take the expected value square root of x square minus expectation of x whole square, right? Now, the all the above properties we can use in this case also. Like, what about standard deviation of a constant?
Zero.
Zero, because it's nothing but variance of that constant, and we know square root of variance and zero is nothing but zero, right?
Yes, sir.
What about standard deviation of a plus x?
Same.
Same what? Standard deviation of x, right?
Yes.
So what is this?
That's
You
the
can
estimate.
simply prove. Prove means like you can simply do standard deviation of x is what? It's nothing but square root of variance of a plus x, right?
Yes.
We know variance of a plus x is nothing but going to be same as variance
X.
of x, right? Okay, and this will be square root, sorry. And you know square root of variance is nothing but standard deviation, right? What about standard deviation of any constant into x?
It's
Tell me.
0.
Why?
a into standard deviation of x.
Standard deviation A, okay, let's do in steps. Standard
The
deviation A
A
times
will be
x is what? Square root of variance of A times x,
Yes.
and square root
yes,
of what is the variance of A times? It's a square variance of x,
Yes. Yes.
right? If you take the
yes,
square root of A square, that will A, and the square root of variance is nothing but standard deviation of x.
Yes.
Got it?
Yes, sir.
I mean, properties are same, just only difference is nothing but square root difference.
okay, sir.
Got it? Okay, so
Okay,
these
sir, I
these
got
three
it.
concepts are clear: expectation, variance, and standard deviation of a random variable, and all.
Yes, yes, sir.
Fine. So let's move to the some questions. Okay, some questions from activity. Okay, and these three concepts are covered in week 10 actually. Okay, so let's do some practical question.
Sir, there is one concept of hypergeometric random variable. Is
In
it
week
an
10, in week 10 itself, hypersymmetry is in week 10 or in week 11, I think.
so
No,
in
sir.
week
It is
in week
not in 10, I think.
Hypersymmetry is again discussed in week 10, week 11. Okay, so there is one I mean separate lecture for this. Okay.
okay, sir.
Okay, in week 10, there is some just a rough idea. I mean, there are some, let's say, emerald ball and
Yeah,
blue ball,
examples.
something like that. Yeah, yeah. So don't worry, hypergeometric, you can discuss. I mean, we will discuss in week 11, okay, separately. Okay,
Okay, sir.
okay, yeah, fine. Okay, what about this? Tell me. So this is something. Okay, so from here I can compute the variance, right? Sorry, expectation. Okay, now tell me. Let's do the quick question. If probability x equal to 0.2 in a Bernoulli random variable, then expectation of Bernoulli random variable is what?
So I think you missed the Bernoulli.
I have done Bernoulli. I took the example with the Bernoulli.
Oh, okay.
Tell me, what was the expected value in case of Bernoulli?
P, sir.
Forgot. Forgot. Everyone forgot. Okay. See, here we discussed, right? Expectation of Bernoulli random variable is what? It's the, nothing but
One.
P, right?
Yes, sir. 0 and 1.
Yes, sir.
We have
You
taken
see,
one.
we got expected value of standard variable P, right?
Yes,
Right?
sir.
And
Answer should be, I think, 1.8 or
no, not
0.8.
1.8. See, what question says? Question says probability at x equal to 0 is 0.2. right? I mean, if you Bernoulli random variable, it will take value 0 and 1, and probability x equal to 0 is 0.2. Then for 1, what will be probability? Probability will be 0.8.
Yes,
And
sir.
you
Yes.
know what is the expected value of x in case of Bernoulli? It's a p.
P.
And what is
Yes.
this p? P is nothing but 0.8. That's all.
Yes. Yes.
Yes.
Got it? Okay. In these two questions, in the seventh question and in sixth question, what you do is simply x into px, right?
Yes,
In
sir.
question number 7, you have to do x into px. Okay. In question number 6, you have to apply this concept actually. R x equal to xi actually. It's not a probability, it's just a frequency. You can find the probability, right? How will you find the probability?
Uh,
Okay,
X multiplied by frequency plus
no, basically
summation.
not multiply, it's frequency divided by total frequency.
Yes, sir.
Okay.
T.
Okay, so you can simply do 15 divided by sum of all the frequency, right?
yes. Yes. Yes.
Okay, see, what is the relative frequency and all? See, basically
Relative
what,
frequency is also a like
correct, correct. It's a
probability.
probability because what probability tells you, it's a favorable case divided by total case, right?
Yes. Yes.
So it's a favorable cases divided by total cases, right? If you see what is the favorable cases in the case of x, when x is going to take value 0, it's a
0.
15, right?
Yes, okay.
And
Total
what will be
case.
the total cases? I mean, you have to add all the probability, right?
Add
You can
all the
simply find
frequency.
the, okay. Yeah. Let's move to the properties and all something. Everyone got the idea, right?
Yes. Yes. Sir.
Okay. Okay, tell me which statement should be true. What about option number 1?
Yes, option 1 is correct.
Option 1 is correct.
Yes, sir.
What about option number 2?
Yes, sir. It's also correct.
Also correct.
Yes, sir,
What about
correct.
option number 3?
It's false.
Not.
Option D is correct.
Also,
D is
Or
correct.
D is correct, right?
D.
Should I
yes.
do the derivation or you got the idea?
No, sir,
Because
no, sir. It's a A plus B ka whole square.
okay, basically, yeah, I will tell you. This is nothing but what I can simply write expectation of ax plus expectation of b, right? And we know a is the constant, then it will be expectation of x, and the expectation of any constant nothing but, so this is something square. If this is a square, you can simply do the square of these things. Expectation of a square x square plus b square plus 2 times of ax into b, and you can take the expectation inside the bracket, you will get the same thing. Okay. What about question number 2? What it says, please read the question carefully. It says expected values of outcomes of 10 biased dice is given in this table. What is the expected values of sum of outcomes of these 10 dice? That means what? It is asking about expectation of x1 plus x2 plus x3 plus x4 up to x10, right? What question? Expected value of sum of outcomes of these 10 dice, right? So basically it is
Yes.
asking expectation of x1 plus x2 plus so on plus x10, right?
Yes, sir.
This is the question. And if you see in the table, what is 3.5? It's nothing but expected value of x1, right? For die 1.
Yes, sir.
2.5
Yes,
is
sir.
Then we can
expectation of
sum
x2.
Right.
Now I can apply this property, expected value of x plus y. If it's two random variables, it will be expectation of x plus expectation of y, right?
Yes, sir.
If it's
Yes.
unrandom variable, it will be simply expanded, right? So you have to add all the expectation, you will get the answer. Is this clear?
Yes. Sir.
Okay,
Okay.
sir.
Now tell me, what about this question? In a software office, there are 20 junior developers, of which 8 are men. I think this question is something related to hypergeometric. Okay. Okay, we'll see. We'll do without hypergeometric. There are 20 junior developers, of which 8 are men, 12 are women. If 5 juniors are to be promoted to senior level, what is the expected number of women in the promoted developers? Okay. Tell me, how will you proceed? First of all, you have to find out the x and respective probabilities. Yes or no? Basically, for this question, you can apply the concept of hypergeometric directly, or else
Yes, sir.
you can do manually. Manually means what will be your x? Suppose x is represent the number of women promoted to the. I mean, they are going to promote it for the senior developers. Okay, how will you proceed then? What will be your x?
X
20.
0 to 5.
0 to 5. Okay, fine. What will the probability associated with each value?
0, I think. 0, I think. 0.
Or
And
0?
1 is, I think, 1 by 12.
We can find out using combination.
Combination, right? Okay. I will give you some sort of idea. You can try it out and you can. Okay, there are 20 junior developers, right?
Yes, sir.
There are 20 out of which
8 are
8
men.
are men, 12 are women. So 8 are men,
Men.
remaining 12 are women. Actually, this is based on hypergeometry. So we will discuss the hypergeometric detail in the
Use
next
the
lecture.
11th
combination.
week.
But we can do the same thing without hypergeometry. I will tell you how. What is so 5 juniors are going to be promoted to senior level, right? So let's say X is representing the number of women promoted to
Senior level.
senior level. Okay. Now, how many juniors are going to promote it? 5. Now, my X
5.
will take 0, 1, 2, 3, 4, 5.
4.
Right? We have
Yes,
to
sir.
find the probability associated with each value, basically. So, this is something hypergeometric. Okay. I mean, there are something capital N. Okay, I will come to that. Okay. What about if X will take 0? That means what? All are men.
1 of 1.
Okay,
Yes.
before to that, what will the total case to select the five people?
All are men.
No, no, no. I'm talking what will the total case to select? I mean, in how many ways you can select the 5 people?
20 C5.
20
20.
20
C.
C5.
So
20 C5.
this will be the total case, right?
Yes.
Now, what is the favorable? So X is going to take value 0. 0 means there is 0 women. That means all are men. It
8
will
C.
be
8
Yes.
8
C5.
C5.
8 C5.
correct. Fine. What about probability? I'm going to write down. What is probability X equal to 1? So total case is
It is,
26, 5. 1
yes.
means 1 woman is
8
there. That
C4.
means
8
uh,
C4.
12
C.
out
C1.
of 12,
12
there will
C1.
be 1 woman
12
into
C1.
8
rest
C4.
rest 4 is men, right?
Yes, yes.
Yes,
Same
sir.
for 2, it will be 2
12
women and
C.
remaining 3 will be from men and divide by 25, right? Similarly, you can
Yes.
find for 3, 4 and
All.
5. Okay,
And
so this is something, some sort of hypergeometric. What hypergeometric tells us? Suppose you have something n things, or let's say n balls. Out of them, let's say small m are, let's say red, then capital N minus m will be blue, right? Yes or no? Suppose this is n, this is m, small m, then this is capital N minus m, right? Yes or no?
Yes.
So what hypergeometric says? Suppose you are going to draw n balls without replacement, then probability for let's say, and your x is representing the red ball, then it will be basically total n choose n, and its x is representing the number of red balls drawn. Okay, so number of red balls drawn. So it will be NCI into N minus M into, I mean, C and choose I, right? Okay. So this is same as this concept. I mean, simply you can find the, and you can simply then find out the expected value of X. 0 into this probability, I mean probability at X equal to 0 plus 1 into probability X equal to 1 plus so on. Actually, in case of hypergeometric, what is the expected value is nothing but small m divided by capital N. So what is the small n in this case? 5. What is the small n? This is number of samples, number of balls we are going to draw without replacement, right?
5.
Okay, so here n is, small n is 5. What is the small m? Small m is 12,
8.
12,
No.
12, 12. Okay. Basically, X represents the number of red balls drawn. Here and here we are interested in number of women. How much?
Women.
How many women is there?
12.
12 women, right? And what is the capital N is
20.
20. So expected value of X, I can directly find out N into M divided by capital N. So it will be 5 into 12 divided by 20. So it
20.
is
It is
it
like
will be 60
3.
divided by 3, right? And the same thing you can find out this expectation formula. You can check whether it's a 3 or not. Okay, so it's a 3, right? So you can
Yes.
find out directly, or else you can go with the concept of
Hyper.
hypergeometry. Both are the fine. Okay.
Hypergeometry, I think, simple like that.
Yeah,
We
it's a
find
simple.
only an.
Okay, so this expectation concept is clear, right? Yes or no? Any doubt?
Yes, sir.
Okay, let's discuss this variance. Okay, tell me Okay, but expectation is clear to everyone. Any doubt? 10.2 question number one. Manish is asking what is the 10.2 question number one. You can unmute yourself, right? You can ask at the same time, no problem. Relative frequency of random variable converges to probability of random variable in the experiment of tossing a die. Okay, what should be the correct? Finite or infinite?
Finite, I think. In a no infinite.
Infinite.
Independent, I think. Relative frequency of
Let's see what answer says. Okay, accordingly, and okay. So it says, in fact, I think Ma'am clearly discussed that relative. Okay, what the relative frequency tells us? Basically, frequency divided by total frequency, right? That and the same thing probability we are doing, right? Probability is what? Favorable case divided by total number of case, right?
yes.
Okay, so basically it convert. I mean, see, it's not exactly same as the probability of see relative frequency, not exactly same as the probability of that random variable. It will converge to that if we are doing this. Let's say I'm going to roll the die large number of times, right?
Yes, longbow diverse
Correct. Long average, like it's a long
logs.
run average, basically,
Yes.
that is. Yeah.
It is
So,
only applicable for
okay,
long
forget
run.
about the average. It's basically when we are going to roll the die or toss the die a long number of times, large number of times, it will be converged to the same.
It is like another type of mean that's
Yeah, it's not a mean. It's a basically see. If you see what is the relative, how we are defining the relative frequency, it's the
no
frequency
sir.
divided by yes.
I am talking about expectation
Okay, yeah, the expectation is different. Yeah. So this is something it says this will converge to probability, and probability is what? Favorable case divided by total case, right? When
yes.
n is infinity, and n means that your trial is number of observations is infinite.
Yes, yes.
Okay, what about tell me? What about this question number first? Okay, anyone can tell me to know the which one has the which random variable has the highest variance. Whether you will calculate the variance for all these four options or you will do something else.
So to find for all.
Any other
No, sir, no, sir. We can also take PMF is equal to 1, then we calculate.
no for everything I think PMF is one.
Then find for all.
Okay, anybody else?
Maximum of x.
That is something you have to find. So I'm asking, how will you proceed? Whether you will find all the variance of x first, then you will see like then you will see which values is highest or any other approach.
We can also find x square. Then
Okay, basically what variance
So
tells
we
us? Variance tells us nothing but expectation of deviation from its mean, right? So
yes, sir.
you can simply check for which of the options has the deviation, I mean more deviation from its mean, right? For if you see for the first option, what is the mean? Mean is the nothing but 5, 4, 9, 3, 12, 2, 14, 1, 15 divided by so 3, right? If you see how much deviation is there, 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3, right? Okay. Are you getting my idea? What about variance expected value of this case? Option number B, 80, and it will be 24
6.
or 30 divided by 5. It's 6, right? Now,
Yes.
if you see how much far is far, so for the first option, it was minus
3.
2, minus 3, right? Minus 2, no, sorry, minus 3, minus 1, 0, 1, and 2. For
Yes,
option
yes.
2, what is the variability? 6, right? So, minus 4, minus 2, 0, and 2 and 4, right? Similarly, you can find out the for third and fourth, and you can simply check for which of the option has the much variability from its mean.
I think option 2 is
Option oh, okay, for option number 3, what is the expectation? Okay, can you tell me what is the expectation? It's a 3, 2, 5, 4, 9, 10 divided by
10
4.
divided by 4.
That means 10 divided by 4, that means it's 2.5.
2.5.
So
2.5.
1 minus 2.5 means minus 1.5.
Yes.
No.
No, I think 0.5, I think.
No,
I
no.
would say.
See, 10 divided by 4 is nothing but 2.5, right? 2 minus
Yes.
2.5 means minus 0.5 and 1.5 and 0.5, right?
Yes.
No. 3 minus 2.5, right? So it's yeah, it's correct. And it's a point.
No,
No,
sir, it's a 0.5, sir.
yeah,
Yes, sir.
sorry.
It will be
Yes.
So
point five.
it's a 0.5 and it will be 1.5.
1.5.
Yes.
Yeah. For the next option, if you see, it's a 6, it's 14, 4, 18 to 20 divided by 4. So it's a 5, right? So it's a minus 3, minus 1, right? 1 and 3. Okay. Now, which one has the highest variability from its mean?
2.
2, right?
Second
Then, if,
option.
rather than going to calculate all the variances, you can simply say,
Sir,
now you
we
can,
have to take a square of that or just simply add.
I
yeah,
guess.
you can do. I'm not denying it. So, thing is that you have to find the variance of x, right? So rather than checking which one has the highest variance, so rather than calculating the variance for all these 4 options,
Yes,
you
sir.
can simply check which one of the has the highest variability from its mean value. Okay.
No, sir.
So
And that values we have calculated, we have to take a square of that or just simply add
no,
it
no,
out.
you can simply do no. Or to calculate the variance, you have to do the square and then you have to find. I mean, simply you have to apply all the formula. I mean, you have to do like this. Okay. If I ask or if question is about to calculate the variance, I told you a simple trick. Just you can check simply which one has the highest variability from its mean, and you can simply take say this will be having the highest variance. That is
Yes.
something
Yes.
I'm trying to say here. Okay. Or else what you can do, you can find the variance of x for option number 1, for variance of x for option number 2, variance of x for option number 3, variance of x for option number 4, and you will check. I mean, after that you will find for option number 2 variance of x is the highest. Okay.
It is a long method.
Yeah,
Then
it's long. What about option number 2? As it's a thing, direct thing, right? Now tell me which one of the following statements whether the variance of a random variable can be negative.
No, sir.
Okay. If the variance of a random variable is 0, then the cardinality of a random variable is 1. Cardinality of a random variable is 1 means it is going to take value only one value, right?
No,
Yes. Variance of a random variable is 0. That means variance of a constant is 0, right?
yes, a
The
constant.
cardinality of that random is only 1. Cardinality of random variable
Yes.
1 means that random variable is going to take only one value.
Yes, sir.
Got it? What about number 3? As the n of the uniform random variable random distribution increases, variance decreases, right? Yes or no? Why? What is the okay? What is the expectation of discrete uniform? It was n plus 1 by 2, right?
Yes.
Okay, I can find it's a 1, 2, 3, 4. It's an and probabilities. It was 1 by n, 1 by n, 1 by n up to 1 by n, right? So what will the x is? I need to calculate x square, right? So it will be 1 square, 2 square, 3 square up to n square. Right?
Yes.
All the probability will be same again. 1 by n, 1 by n, 1 by n in up to 1 by n, right? What about expectation of x square here? If you see, it will be 1 by n, 1 square plus 2 square up to n square. What is
Yes.
this quantity? You can remember, right? I mean, this is something n into
and
n
and,
plus
and
2,
And plus 1 by.
2n plus 1 divided by 6 or
Yes.
12, right?
six. Yes, sir.
6, right? So this will get cancelled out. So we got n plus 1 into 2n plus 1 divided by 6, right? Is this correct?
Yes, sir.
Not sure about
Sir,
it.
it's right formula.
Is that okay?
Sir,
Fine.
Yes.
it's right formula. Yes,
Okay.
sir.
So what is the variance of x if you see? It's the expectation of x square minus expectation of x whole square, right? So you have to do n plus 1, 2n plus 1, divided by 6 minus expectation of x is whole square, that is n plus 1 divided by 2 whole square, right? Now, I can simply do n plus 1, 2n plus 1 divided by 6. It will be n plus 1 whole square divided by 2, sorry, 4.
4,
Right?
yes, sir.
What will the LCM for this case?
Two.
Or I think I can simply do,
12.
Multiply by, I think.
you can simply cross multiply, right?
12.
Yes.
It will be 4, right? N plus 1, 2n plus 1 minus, you can simply take, it will be 6 n plus 1 whole square divided by, let's say, 24.
24.
So I can take 2 times n plus 1 as a common, right?
Yes.
So it will be 2 times of 2n plus 1 minus n plus 1 divided by
No, sir, sir,
24.
it's three time. Sir, it's three time.
No, no, I have done cross multiplication. I did not do LCM.
No, sir. Sir, in
Hmm.
second step,
Common part.
sir, it's
Okay, okay,
6.
yeah.
6.
Fine, fine. Thanks.
yes.
Yeah. So 2 n plus 1, and what we got? It will be 4n plus 2 minus 3n minus 3 divided by 24. So basically we will get, it will be 12, right? And it will be
Yes.
n plus 1, and it will be n minus 1, right? Divided by 12. Basically n square minus 1 divided by 12. It's the variance of n. So now this is something it says variance as the size of uniform random distribution increases, variance increases, right? Variance will increase, yes or no? If n will is increase here, variance will increase or not?
Yes, sir. Sir,
Increases, sir.
Correct? Correct.
Yes.
Suppose, for example, where n
Yes,
is
sir.
for any random variable, n is coming out to be in denominator. I'm not going to suppose this is something else. Then if n will increase, then what about variance will decrease or increase?
Yes. Decrease.
It will decrease, right? But in this case, n will increase, then variance is going to also increase. Okay. Variance of a Bernoulli random variable is maximum when p is equal to 0.5. Is this true?
Yes.
Okay, you can simply do like this, because variance of a Bernoulli random is what? It's nothing but p into 1 minus p, right? Then we
Yes.
can check the maximum. How will we are finding maximum? And we have to find the derivative, right? And we have to equate it with 0. And if you are going to find the second derivative, it should be less than 0. Then that is the maximum, right?
Yes.
So if you will calculate, so at p is equal to 0.5, it should be. It, yes, do you any query?
Yeah, sir. So can you repeat that previous slide one and concept? The last. Yeah.
Okay, so if you see, variance is here in n square minus 1 divided by, so n is in the numerator part, right? So
Yes,
if
sir.
you will increase n, okay, for example, n is, let's say, 6, okay, it will be 36 minus 1 divided by 12, it will be 35 divided by 12,
Yeah, sir.
okay. Suppose n is 10, so it will be 100 minus 1 divided by 12,
99
that
by
is,
2.
so it's increasing, right?
Yes, sir.
Okay, so I took some random example. We don't know. Suppose n is in the denominator of that random variable. I'm saying variance of x is something in the numerator part. In the denominator, suppose it's n. Then if suppose I will increase n, then whether my variance will increase or decrease?
Decrease.
It will
Decrease, sir.
decrease, right? That is
Yes.
something I wanted to explain. Is it clear?
Yeah, sir.
Fine. So this is something you can try it yourself. Okay. So this is something you can find out the how maxima of anything, right? So in case of Bernoulli, P is 0.5, 1 is at 0.5. So now tell me, if Bernoulli, if in a Bernoulli random variable, whose possible values are 0 and 1, probability x equal to 0.5, what is the variance? If P is 0.5, right? So variance of Bernoulli random is nothing but P into 1 minus P. That means 0.5 into 1 minus 0.5, which is nothing but 0.5 into 0.5, which is nothing but again 0.
2.5.
Okay. This is the answer. Okay. Now simply, okay, this is what kind of these things? Tell me. Very okay. This, what kind of distribution is this one?
Discrete uniform.
Okay, and we just find out discrete uniform. Okay, what is the variance of discrete uniform? It's n square minus 1 divided by 12. Okay,
Yes.
what is
Yes.
the n here? 20, right? So it will be 400 minus 1 divided by 12. That means 399 divided by 12. Can you calculate it?
It is calculator. We use calculator.
Yeah, it's a 33.25. So if you see 33.25 is the answer. So if you are able to identify whether it's a discrete interval, we can directly apply the formula, or else you can do the, you can apply the formula of variance and you can do the manually, means expectation of x square minus expectation of x whole square.
Sir,
Got
can you
it?
please move to the answers slide?
Here,
Yes, sir. Okay, sir.
got it? So this is some sort of idea is okay. You are getting the idea, everyone?
Yes, sir.
So let's do some questions from activity 10.5. Question related to variance property. Okay, tell me which option should be correct.
Sir, A.
A. Anybody else?
Yes, sir. A.
No, sir. No, sir. B option,
No,
sir.
B. Okay.
B
No,
option.
V is not
A.
correct.
sir. A
A correct.
option is correct.
A,
I'm
sir.
get, okay. I'm getting the majority with option number A. Let me do. So variance of A square x plus B square. A and B are constant. Okay. So I can simply do, and we know variance of A plus x is what? Nothing but same as variance of x. There is not any effect of adding a constant, right? So I can simply say variance of A square x. Yes or no? Yes. Are you getting?
Yes, sir.
Okay. Now I know variance of any constant, variance of a times x, nothing but a square variance of x, right? Yes or no?
Yes,
Here
sir.
already a square
Yes,
is
sir.
there. It will be a square of a square, right? So it will be a raised power 4 variance of x. Is this clear?
Yes, sir.
Got it, sir.
So third option is correct, not the first or second. Got it?
Yes, sir.
Okay.
Yes,
Tell me
sir.
what about question number B? Or question number 2. Variance of marks obtained by a student in statistics, let's say variance of S is 24, and the variance of marks obtained by a student in mathematics, let's say is 26, then what is the value of sum of marks in statistics mathematics, variance of S plus M?
So we
Tell
can
me.
add separately
Yes, I
24
think
plus
that is
20,
something you have to
Yes,
identify. We
50.
can add, right? Because both
Yes,
subjects are independent, right?
Yes, sir.
Yes.
50.
So it will be simply 50, right?
Yes.
You can
yes,
check
sir.
you can check the answer. If you click here, so you can see 50 is the answer, right?
Correct
Okay.
answer. Yes.
Tell me about this question. I'm going to give you some 2 minute, 1 minute, 2 minutes. Tell me what will the answer. Variance of number of tickets sold in a day in a opera theater is 25. If for each ticket sold the profit obtained is 25, what is the variance of the profit? Don't click on the answer. Tell me how will you find? Are you trying? Anyone? If you're not getting, you can let me know. We can discuss it. If you're trying, then that's also good. Fine. Yes, no. Anyone?
No, sir.
You're not getting?
Yes, not really.
Okay. You will. Okay. Anybody else? Those who are trying.
0
Okay. Why?
because 25 minus median is equal to 0.
Yes. Yes. Yes.
25 minus. Okay.
Median
What is the okay? What is median? Where is the median?
between f
Median not. It is like
Okay. Okay. For the what's the information we have given?
we have 25 tickets and each ticket have 25 profit as.
Okay. So one second. Give me 1 minute. Okay. So what is the information we have given? Variance of number of tickets sold in a day in an opera theater is 25. Let's say my random variable is number of tickets sold in a day in an opera theater is X. Okay. So I'm saying my X is number of tickets, okay, sold in an opera theater, okay, in a day basically, a number of tickets sold in a day in an opera theater. Okay, so this is given to us. Variance of X is what is this? 25.
Yes, sir.
Okay, now what the next information? If for each ticket sold the profit obtained is 25 rupees, then what is the variance of the 25? Sorry, what is the variance of profit obtained in a day? Okay, tell me what is meaning of this? If for each ticket sold the profit obtained is 25 rupees.
Sir, we get 25 rupees in each ticket.
If he sold a one ticket and he get profit as 25 rupees.
What is the meaning of it? How will you represent in random variable terms of random variable?
Sir,
25 will be the constant value, 25 rupees. So it's
Okay, okay,
25.
okay. Suppose he is going to sold one ticket, then how much profit he will get?
25.
25.
25.
If he will sold two tickets, then what is the profit?
50.
50.
50.
If he is going to sold three tickets, then
1.
75.
then
75.
what we are doing? 25
We are
into
just
2,
25
25
adding.
into 3.
Yes. Yes.
yes.
If X is represent number of tickets sold, suppose X is represent number of tickets, so basically we have to find out the variance of 25 times X.
Yes.
Suppose for one ticket 25 rupees, for two 25 into 2
Yes, I
for
got it.
so for X what will be 25 times X or not,
25x. Yes, sir.
Yes.
right?
Yes.
And variance of any constant is what? A square variance of X. So
Yes.
it will be
Yes.
25 is square variance of X. So 25 is square nothing but 625. What is the variance of X? 25.
20.
Yes.
This is
Yes.
nothing but 15 625.
Okay, sir.
Clear? So basically you have to identify the things. Rest calculation and things are very easy actually. Okay. What about question number 4? We have discussed just few minutes before. If x and y are independent only, then the variance of x plus y will be same as variance
Yes,
of
sir.
x plus variance of y.
Yes,
Right?
sir.
Second option is not going to be true, right?
Yes, sir.
Same
Not
third,
Yes,
true.
sir.
then fourth will be true, right?
Yes, sir.
D.
C
So,
and D.
okay. So are you getting the idea, right? Behind the concept which we have discussed, right?
Yes.
Let's move to this activity 6.1. Sorry, not 6, 10.6. Okay, what about question number 1? Which option should be true?
Option B.
Option?
D.
That's all?
Option C, I think correct. of
Okay. What about question number D?
standard deviation of
So basically, it
n
says,
unit.
yeah, tell me, take your time.
Yes, option number C also correct. Like
Right? Basically, what tells? Okay, let's see. Let's check the answer whether you are correct or not. So you are correct. Basically, standard deviation. Okay, first option is not correct because it should be minus, right? Expected value x
yes,
square minus mu square. Okay, that's
Yes, a minus.
second is correct. So what third option is saying? Standard deviation of a random variable has the same units as the expectation of a random variable. Okay, okay, because
Yes,
suppose x is the weight of kilogram in I mean weights of a person in kilogram, then expectation of x is also will be, let's say, some 45 kilogram, right?
yes, sir.
Then standard deviation will also have some same unit, right? And option number 4 is also correct because standard deviation gives us the same unit as the random variable, right?
Yes,
What about question number 2? X and y are independent, then two information we have: variance of 3x plus 3 equal to 27, variance of 5y plus 10 equal to 150. What is the value of standard deviation of x plus y? Okay, would you like to try? Yeah, just try it. Yes, you can take some 2 to 3 minutes. You will try, you will get some idea. Basically, okay, let me give you some sort of it. What is the
no,
very
I
standard?
think we add the variance of and take under root of this all.
Correct.
Add
Basically, standard deviation of x plus y means what? See, all the things is given in terms of variances, right? So you have to find the standard deviation of x plus y. I can simply find the square root of variance of x plus y, right?
yes, yes,
And since it's information x and y are independent, then I can simply say variance of x plus variance of
y.
y. So key thing is here you have to find out the what is the variance of x and what is the variance of y. Now those value you have to tell me.
9. Variance of x is 9,
Okay,
and variance of y is 30.
30, right?
Yes.
Okay, let's wait for other.
30.
Yeah, you have made a mistake. I will let you know what is that mistake. Any
Sir,
mistake?
3 and 6.
3 and
3
6.
and
Variance of x is equals to 3 and variance of y is equals to 6.
yes,
I,
yeah, correct. Basically, why they she got 9? Okay, basically we have to find. Okay, so far this step is clear,
and
right? Yeah,
and
first of all,
standard deviation of x
one
plus y
second,
is
one. Yeah,
equals
yeah,
to 3.
yeah, that's correct. I think 3 is the correct answer. Yeah, let's discuss this thing. First of all, tell me this till this step it's fine, right? What we have to calculate. So what we have given variance of 3x plus 3, right? I think, yeah,
Yes, yes,
it's a 27, right? And variance of 5y plus 10 is 150. Okay, so if you see, this is same as variance of ax plus b, right? So
yes.
there will not be any effect adding constant, so it will be same as variance of 3x is nothing but 27, and
Yes,
variance of same here 5y will be
50.
150. And we know variance of ax is nothing but a square variance of x. I think those, I don't know,
9.
are there?
It's 3. It should be
I,
3.
yeah, it should be 3. So this is incorrect. I think you have done 3 times of
3.
variance of x, but no, it will be
Yes.
3 square variance of x.
Square.
Okay? So make sure these kind of mistakes is normally happen during the exam pressure and all. Okay, so keep this kind of I mean, uh, take care of this kind of things. So it will be 9 times variance of x 27, 25 times variance of y is equal to 150. So variance of x is 3 and variance of y will be 6. So if
6.
you can simply put value here, it will be 3 plus 6, which is square root of 9, which is nothing but 3. So 3 is the answer. Now, are you able to relate how you can apply the concepts? Yes or no?
Yes, sir.
Yes.
I'm going to give you some 3 to 4 minutes. Just do the question number three. Okay. Then I think if you are able to do, that means it's fine. Okay? I'll be back in 2 minutes. Okay. Just do, and I will discuss in 2 minutes. Hello. So are you able to solve it, or you're facing difficulty? Yes. No. Any opinion?
Root 17.
Root 17. Okay. Answer is 5. I think root 25 should be there. Maybe. Okay. No problem. We'll see. We'll see. I don't know whether the answer should be 5. So let's see. Anybody else who are getting the answer, or should I solve it?
Sir, solve this.
You are not getting?
Yes, I getting wrong answer.
Okay. What about others? Okay. Let me do it. Let me do it. No problem. Okay. So first of all, what the information is given? We have. I mean, information is we have three random variables, right? Out of those three, only x and z are independent, right? Not x and y or y and z, right? Are you getting? So basically, I mean, suppose they are okay. Have you learned that concept? If there are three events, let's say A and B, if this okay, if there are two events, when it will be independent, when I will say intersection of these two is same as probability of A into probability of B, right? If there are three events, when all these three independent, intersection of these two should be, I mean, this it should be jointly independent, right? Yes or no? Only then you can say this. I mean, these three events are independent. I'm talking about in terms of probability. Okay. So these three conditions should be satisfied if all three events are independent. The same thing will apply in case of two random variables. Sorry, three random variables. It should be jointly independent, and this case also. Okay. But what information we have given? We have given only there are three random variables x and y, x, y, and z. Okay, and y is defined as 2 times of x. Okay, and we have given x and z are independent, right? Only these two. This okay. Now, see, just go step by step. It will help you. Don't do the things directly. If you are going to do things directly, then I mean you can do that directly once you have lots of practice and all. Okay. And what's the another information? Variance of x is 2 and variance of z is 7, right? And we have to find out the value of standard deviation of x plus y plus z. So basically, I have to find the square root of variance of x plus y plus z. Yes or no? Let's make it equation number start. So let's solve it variance of x plus y plus z. Okay. What is the if you see what is the value of y? Y is nothing but 2x.
Yes,
I
sir.
can
Yes.
replace 2x, right? Yes or no? I can simply replace in the place of y. I can simply write down 2x or not,
Yes, sir. Yes, sir.
right?
Yes, sir.
What it will be variance of 3x plus z, right? And we know x and z are independent. Then I can simply write variance of 3 times of x plus variance of z. Yes or no? Are you getting? See, we have information x and z are independent. I can write
Yes.
down variance of 3x plus variance of z, right? And what
Yes.
about this? It's nothing but 3 square variance of x plus variance of z, right? And it will be 9 into what is the variance of x? It's given as 2
Two.
plus 7. So it's nothing but 18 plus 7, which is 25. So variance of x plus y plus z is 25. So standard deviation of x plus y plus z will be square root of variance of x plus y plus z. Okay, it will be square root 25, which is nothing but 5. Okay, 5 is the answer. Is this clear?
Sir.
Yes, sir.
Clear, right? So simply we have to apply the concepts. Okay, okay. So all the properties are clear
Okay,
to
sir.
everyone.
Yes, sir.
All the properties, all the concepts. Okay.
Yes, sir. Yes.
Okay, so then I think we have discussed the things. Is there anything else, or we can wind up?
No, sir.
Okay, I think from 8 p.m. you will be having some session, right? Or it's not?
Yes. Yes, sir.
Okay, math
8:30.
maths one, right?
Yes, sir. Maths one.
Okay, okay, okay. Then thanks,
Sir,
everyone. Yes, yeah, please go ahead.
sir, can you explain hypergeometric concept once again, if it is
Okay, so
possible?
basically we can so there is one separate lecture in week 11. Okay,
So
Okay,
this
regarding
sir.
this
hypergeometric. Okay.
concept in week 11.
Yeah, but if you want, I will give you some sort of idea, okay? Some rough idea. Okay, basically, what is the hypergeometric? Suppose I have some n balls, okay, capital and total balls. Out of this capital N balls, let's say small m are red, okay, and then capital N minus m are, let's say another color, let's say blue, okay. Now, question is, suppose I'm saying I'm going to draw small n balls without replacement, okay. I'm drawing a ball at random, okay, without replacement, okay. And my random variable, suppose x is defined the number of red balls drawn, okay. Then what? How will you define? And probability x equal to I means what is the I means what is the probability that x will take, means we have drawn I red ball. So what is the probability? It's a simple probability. Means basically what is the total number of case? In how many ways you can draw small n balls out of capital N balls? N, C, N,
Yes,
right?
sir.
And what is the favorable case? I have to draw I red ball. That means in how many ways you can do? Tell me. In how many ways you can draw I red ball without random? Sorry, without replacement. MCI, right?
Yes,
Yes.
sir.
Sir. Are you getting?
Yeah, yeah,
Because
sir.
we have only M red ball. Okay. But if you see in how balls we are drawing total n balls. That means remaining n minus I balls we have to draw from the blue ball. That is the something hypergeometric. Here your x will take value 0, 1, 2 up to n. Okay, the same concept we applied in case of that women promoted to senior level, right? Got it. So this is something hypergeometric. Okay. Okay.
Yes.
So in week 11 we have separate lecture for I mean in detail we are going to discuss hypergeometric random. Okay.
Okay. Okay.
Okay. Anything else, or we can wind up?
No, sir. Thank you, sir.
You got right. You got the idea.
Yes.
Okay.
Yes, sir.
Okay. Okay then. Thanks, guys. Bye bye. We'll meet in the next.
Thank you.
Okay. Thanks. Yeah.
Okay.
Bye bye.